Okay, day 8, we're moving into reflections, but we're just got a quick little warm-up here, and just a reminder of just basic algebraic and geometry skills. So we have some tables, we want to know which one works with. I would give you a hint that you might want to start with x of 0 because it's very easy to calculate, and I'll give you some clues about what's right. So if I plug in a 0 here, that makes this go away, and I end up with 3. Well, that's a possibility. That's a possibility, and that's a possibility, but this is not. So right there we ruled out one of the answers. I could do any of these numbers, but I'm going to pick something with a coefficient of 3. I'm just, this is a smart way to go about a multiple choice question. So I have a 3 here. I'm going to plug in 2/3 of 3, x plus 3. The 3's cancel. I end up with 2 plus 3, which is 5. So there's my answer. I don't have to go through and prove any of the ones wrong. That's my answer. Okay, so day 8, reflections. We're going to be able to draw reflections on a coordinate plane. A reflection or a flip is a transformation over a line of reflection. Each point is a pre-image, and its new image is the same distance. This is very important. This is kind of a cheat too. Same distance from the line of reflection. That's going to be your reference point. So ABC becomes FGH. Another way to do that, again, is A prime, B prime, C prime. Okay? So you'll see it referred to both ways at times. Reflection across the x-axis. So remember, this is your x-axis, this is your y-axis. In other words, what we're talking about doing is taking a shape that might be up here and folding it down into this quadrant. So it ends up going upside down like so. Okay? Well, the thing I told you was so important before, let's say this is 3 spaces away, this is going to be 3 spaces away. It's just folding over that line the same distance. Okay? So notice, this is at 4, 1 right here. This is at 4, -1. Because remember, the y value talks about up and down. Okay, the x value is left and right. So if we're moving down, that's why the y changes. And look what happens. X stays the same, and y just becomes its opposite. So the 7 stays the 7. Because you're not changing the distance out from 0. You're only changing from 3 up to 3 down. Consequently, if you're folding across the y-axis this way, then y stays the same, but x becomes its opposite. Because the height isn't changing, the depth isn't changing, the only thing that's changing is how far you are away from the y-axis right here. So you're still 3 up, but 2 becomes a -2. So here we go. We are folding across the x-axis. Okay? Right here. Which means x is going to stay the same. So first let's find the points. ELP. So E is at 1, 2, 3, -3. 1, 2, 3, 4, 5. Let's see if I can do these right in tonight's notes. L. 1, 2, 3, 4, 5. Yeah. -1, down 1. And P, this is the challenging one for me evidently. 1, 2, 3, 0, not 1. Okay.
That'd be a -5, -3.
Okay, so much for my success rate. Thank you. So, I was just seeing if anybody was paying attention. What we're going to do is we're going to fold this bad boy up this way. None of my x's are going to change. So I can go ahead and put my x's in right now. Because they won't change. And all I do is take the y's, if they're correct, which now they are, and make them opposite. So my -5 is going to become +5. My -1 is going to become +1. And the opposite of 0 is just 0. There is no opposite. So P prime is actually going to be in the same spot. E is just going to come 1, 2, 3, 4, 1, 2, 3, 4, 5, it's big enough, right up here.
So that's going to be E prime. So I put it out. And then L prime is going to go right here. And there's my new shape. Just folded. If you could imagine taking your paper and folding it, that is exactly where it would show up. Okay, now we're folding against the y-axis. Okay, so once again, let's see if I can do this correctly this time. J is at 1, 2, 3, 4, 5, negative 5, positive 1. So proud of myself. U, 1, 2, 3, 1, 2. So negative 3, negative 2. 2 for 2 so far. Z, negative 1, 2, 3, positive 1, 2, 3. Negative 3, positive 3. Okay. Now, when we are folding this across the y-axis over this way, well, Z is still going to be on this line. J will still be on this line, and U is still going to be on that line. The Y's are not going to change. So I can go and put these in right now, because the height won't change. Only thing that does change is I'm making it opposite. So, 5, 1, 1, 2, 3, 4, 5, 1. That's J prime. 3, negative 2, 1, 2, 3. Oh, that's supposed to be positive 2. No, that's the same. That's still negative 2. I'm correcting myself and messing up. 1, 2, 3, negative 2. So that's U prime. And then Z is going to be at 3, 3. 1, 2, 3, Z prime. So I connect the dots, and it is a complete, exact reflection across the y-axis. Okay, now this is when it changes a little bit. And this is the challenging part. When you're reflecting across a line like x equals 3, which is a vertical line, because think about it, x is always 3. So you're going to end up with a vertical line at 3. So I suggest you go in at 3, 1, 2, 3, and at least put a dotted line, some reference point where you're folding it. Okay? Then you go and put your letters. So H is at 1, 1. This time it is 1, 1. J is at 1, 1, 2, 3, 4, 5. 5, not S. S is at 1, 2, 3, 4, 5, 1. And Y is at 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay. Now, what you do, since you're folding it across a vertical line, same thing as when we fold it across the y-axis. Okay? But instead of moving all the way over into this quadrant over here, it's just going to flip across this line. So what you do is you count from this line right here. So let's look at J. J is right here. It's 1, 2 spaces to the left. So we fold it 1, 2 spaces to the right. H is 1, 2 to the left. It's going to go to the right. S is 2 to the right. It's going to go left. So basically, S prime is going to go where H is, and H prime is going to go where S is. Y prime is going to stay right there because it's on the line. So let's see what we have here. J prime is the easiest one. 5, 5. Y does not change. It's at 3, 4. And then basically S and H are just changing spots. So this becomes 1, 1, and this becomes 5, 1. And if you drew it, so J goes down to Y, which goes down to H, which comes over here, and it folds over like that. So if you remember the last one in your homework on 1-7 had those two shapes that kind of folded over each other, and it looked something like this, and you had something like this. That's horrible. But it looked something like that. That's because it was a reflection over a line somewhere in the middle of it. That's what was happening. It just happened to be, it was also a translation because one of them was slid down a little bit. Okay, reflection across the line. Y equals -3. Well, once again, we go to y equals -3. 1, 2, 3. And we put some kind of a reference right there. And now all we do is count up and down. So M is 2 above the line. So M prime is going to go 2 below that line. P is 2 below. So I'm going to go 2 above with P prime. E is 1 below. So I'm going to go 1 above that line with E prime. And then I connect my dots, and there's my triangle. Kind of forms a funky looking X. So real quickly, we put our points in. 1, 2, 3, 4. 1, 2, 3, 4. -4, -4. M, 0, -1. And P is at 1, 2, 3. 1, 2, 3, 4, 5. So -3, -5. So E prime ends up being at 1, 2, 3, 4, down 2. So -4, -2. M prime ends up being at 0, -5. And P prime ends up being at 1, 2, 3, -1. Okie dokie. Pre-image, new image. Draw a rectangle with vertices E at -4, -1. F at 2, 2. I like to put my letters in second after I know where the shape is going. 3, 0, and -3, -3. So now, E, F, G, H. There we go. We're folding across the x-axis, which again is right here. So basically we're going to count up and down. So let's start at E. E is 1 below, so E prime is going to go 1 above. F is 2 above, we just count down 2 below. G is on the line, G stays. And H was 1, 2, 3 below, it's going to go 1, 2, 3 up. So there's H prime. And it ends up looking like that. So E prime is at -4, +1. F is at 2, 2. No, F prime, sorry, is at -2, -2. G prime is at the same spot, 3, 0. And H prime is at -3, +3. But remember, if you look up here at the x's, -4, -4, 2, 2, 3, 3, -3, -3. The x's don't change, and all the y's became their opposite, except for the 0. Okay, pretty simple stuff. Triangle with vertices J, 3, 2, 1, 2, 3, 1, 2. That's J. K is at 2, -2. That's K. L is at 4, -5. That's down here. We have our triangle. We draw it right there. Now, we're folding across the y-axis. We don't actually have to draw this, remember, because across the y-axis means now it's just going to move over here. Okay, so here's my y-axis here. I'm 1, 2, 3 across, 1, 2, 3. Well, if you just look at that, that's at -3, +2. Again, if you look at the original, what changed? 3 became -3. Okay? So on K, 2 is going to become -2. And this is going to stay the same. And this is going to become -4, and -5 is going to stay the same. So sometimes you'll be required to draw it, and sometimes you won't. It just depends on what it's asking for. But you can do it without drawing. And then reflection over y equals x. This is a funky looking one. This is a really weird fold. So what happens is basically all the x's switch places with the y's. That's it. So
X becomes Y, Y becomes X. It's kind of like an upside down world. So reflect A, negative 5, 2. So negative 5, 2. That's great. It has to be in the middle. So negative 5, negative 5, 2. So A is right there. If I was going to change that, it's going to end up at 2, negative 5. So positive 2 down here, negative 5. And you can see if you looked at it in a weird way, it is diagonally flipping across that line. B at negative 1, 4 would be right up here. So B prime would be at positive 1, no, sorry, 4, negative 1. You just switch them. So this is B. You go to 4, negative 1, and that's B prime. Again, diagonally reflecting across that line. So again, we're going to reflect. We're going to put J at 2, 2. Well, that's not hard to reflect because when you switch the spots, you end up at 2, 2. Because it's on the line. So there's nothing really to reflect. 0, negative 4 is down here. So M prime is going to be a negative 4, 0. Right here. So this point here is J and J prime. And this is original M.